Hi, good afternoon and welcome to today's webinar. My name is Lorenzo Bossi. I'm the Sales and Marketing Manager here at CompoSIDE, and joining me today is our application engineer, Jonathan Evans.
Hello everyone.
Today we'll talk primarily about the design of cost-effective composite parts and products using Pultrusion as a manufacturing process. The webinar is scheduled to run for about 1 hour. We'll include some time for question and answers at the end of the presentation. But should you have any questions at any time, please do feel free to post them at any point in the questions panel, which is on the right-hand side of your screen. This webinar is going to be recorded and uploaded to the CompoSIDE YouTube channel, along with all our previous webinars and the over 70 tutorial videos we have about CompoSIDE. You will also be notified by email once the video and the presentation are made available on our website. Okay, so for today's agenda, we'll just start with a relatively brief introduction to CompoSIDE. This is primarily to give you a bit of background on what we do and what you can achieve with working with our software. But we'll then focus on the subject of the webinar. Initially with an introduction to the main advantages and disadvantages of Pultrusion, and then with a live design demonstration for a given profiles and grillages. Following the demonstration, we'll have some time for question and answer, 10-15 minutes maybe. And again, please do feel free to type those as they come up during the presentation. Okay, so just for a brief introduction to CompoSIDE. So CompoSIDE stands for Composite Software Integrated Design and Engineering. The software was launched commercially in early or January 2015, so last year, following 5 years of research and development and software development. CompoSIDE has been quite successful since the very beginning. Following the launch, we had over 150 companies that registered in the first year alone. Now, the software was developed by composite engineers and composite experts that had identified a gap in the market for a dedicated software for composites application. Since its conception, it has been developed to provide a highly efficient design process from the product conception to the detailed design. And the integrated approach means that we are able to basically cover all of the product development, since the material selection down to the provision of laminate tables, for example. Alongside with those, there are also automated reporting tools such as bill of materials, dedicated sections in laminate reports that we'll see later on. Now, CompoSIDE being primarily a small company, we felt that it was important that we supply a software that was affordable and scalable in his licensing system. This is to avoid smaller company having to look at 4 or 5 different solutions, some of which can be in the tens of thousands for a single license, but they still need to be able to do all the development process in-house. So when you're working with composites, the first step is generally the material selection. And there are many base materials to choose from, fibers, adhesive, resins, cores. There are perhaps even too many of those. But what is important is that there are some key decisions that are made at this point. And those decisions can actually greatly affect the final product cost, whether it's per part or the entire production line. One additional aspect of selecting the right materials is also understanding the testing and the qualification process. Depending on the industries, that can be done on the final product or can be a certification required, since the material selection, for example, in aerospace or defense, you would have thousands of investments just at the beginning of the development process. Following the material selection, we enter into the engineering, or let's say the design side of things, and there are numerous tools and processes that we can use. Initially, we would look at using classical laminate theory tools or spreadsheets. We then start conceptualizing the design, and then use computer-aided designs, CAD, CIA, computer-aided engineering, or finite element analysis tools in order to assess the performances and modify our design system. Another important aspect is that of the process, not only for the material itself, but also for the final part and products. What is important here is that there are a number of processes that are used, each of which can basically affect the economy of scale of your product and effectively make it a success or not. What is important in this process is that this is very much iterative. So when we select the material, we engineer the parts, we need to keep an eye on the process. Sometimes, on the other hand, we are fixed by a process because of the, let's say, cost containment, for example, and we have to work with the material and the engineering tools in order to make the most out of it. And what we're trying to represent here is that all those different steps are all pretty much included into the CompoSIDE platform in order to support you in the application or in the development of your parts. So when we look at CompoSIDE, we look at tools that allows us to provide an efficient project management, composite dedicated tools for materials and laminates through ply generation, extended classical laminate theory. We also look at dedicated 2D and 3D engineering tools, either within the platform or as an integration to third-party tools such as other CADs or FEA softwares you may have yourself, or manufacturing simulation, down to the fine details of the manufacturing process and the, for example, laminate tables to be included in manufacturing drawings. So what you see here is the desktop of CompoSIDE. So this is what gets once you are logged in, and you can see there are a number of icons which represent different models. Some of those are specific to other industries such as marine or wind or tidal energy generation. But we can look now what are the main ones that are used in the process of creating products for Pultrusion. So the first model we look at once we enter into CompoSIDE is project space. Project space allows us to define our projects. So if you're working on different products, they can be in or in multiple projects. But what is important here is that CompoSIDE is a multi-user environment, and hence you can actually manage the rights of each user for a specific project. So for example, let's say you can have 5 designers, 3 of which are working in one project and the 2 others do not need to have access to it for various reasons. You can also customize your project details such as safety factors, failure settings, or bill of material settings. That's, for example, usage and wastage factors for a given manufacturing process. Now, this is, if you're working primarily in a single industry, that's probably less relevant because all your projects will be subject to a given safety and failure settings. But if you're working across industries, let's say wind, aerospace, marine, constructions, then it is clear that having the ability to define different safety factor and failure settings per project according to your goals helps to basically manage all the documentation without having to worry about using wrong settings. And finally, project space provides an overview of all the material supplies, laminates, products, or design beams and panels that are within a given project. CMDB is the CompoSIDE materials database, and it includes a module called Playgen, which is well, for ply generation really. What it does is that those module allows you to build your own dedicated material library. So you can include your base materials with all the needed properties, create and evaluate new plies through dedicated micromechanics. And it's also a tool that helps you to basically manage your material properties. Those can be in the order of tens to thousands. And you're able to see, for example, the properties for calculation for a given material. You can compare materials through normalization charts or simply tabular data, or you can select materials out of with the help of scatter plots, for example, and refine your selection in order to identify the ones that are best fit for your project. Materials are organized in what is defined a company library and a project library, and that basically helps you to, one, standardize all the materials data that are used across the company. Although sometimes as an engineer you may want to quickly create a product to use in your project just to make some what-if scenarios, but what it does is that it prevents you to publish this material to the company and hence pollute the company database with just temporary materials. If you are developing materials, there are otherwise ways to elevate the project material to a company material. So there are also those workflows that are implemented. CMDB is a materials management tool. What we also supply separately is what we call the CMDB add-on, which is effectively a material library with 1,250 plus materials and all the relevant data. That include composite specific materials for cores, fibers, adhesive, resins, but also non-composites or other-based materials, woods, plywoods, plastics, and metals. Alongside those, there are also 800, well, close to 900 plies that are ready for usage within CompoSIDE itself. All the data we provide is manufacturer independent. That means that we provide characteristic values. We can, for example, give you characteristic values of unidirectional standard modulus 200 GSM epoxy prepreg carbon fiber. So those are the values that you will find across the industries. And all is compiled through usage of multiple sources, whether it's internal or external testing. For some, like metals, is obviously standardized, so those are fully documented in the material datasheet. All those materials are fit for design and FEA. That means they basically contain all the data needed for you to run your design and your analysis. Alongside this, there is the option to export to third-party CAD and FEA tools for material plies and laminates, supporting ANSYS, NASTRA, and OptiStruct radius as native formats. There is otherwise the option to export the data to Excel or to create your own data format by calling in the CompoSIDE API. I mentioned the concept of material libraries. So what you see, for example, here is called My Company Materials. Each of our customers has a private material database. We supply close to 60 materials to start with. Even if you are in trial, you'll get those materials to get started working with CompoSIDE. And then if you need, you can actually complement your library with the CMDB add-on or CS material library, which basically contains those 1,200 plus materials ready for design and FEA. Your project materials are basically dragged and dropped into your active project materials folder that allows you to work from a subset with a smaller subset than all the library that you have in your company, or if you have acquired the CS material library. And those can be further refined down in material selections that can be per part, products, per type of material, or as you prefer. As you can see, all materials are also defined by manufacturers and a wide range of material types. Lamina space is the module dedicated to laminate definition by using extended classical laminate theory. What it allows you to do is not only to create a family of laminates, but also to create a limited number of sublaminates with unlimited plies. So that would be useful, for example, if you're looking at single skin or also products with cores. Extended classical laminate theory allows you to review engineering constants, allowables through thickness shear, sandwich stability, perform load calculations, and also review coefficients of thermal expansion. So all the data that is basically needed to perform your hand calculation at the beginning of the project, validate some data and some assumptions before doing some more heavy modeling. It also allows you to basically manage all your laminates. So you can review and store your laminates. You can automatically create detailed reports for the laminate, also subject to specific loads. And you can create shells or export laminate tables directly from the laminate page, alongside with, I mentioned earlier, or the export to FEA and CAD systems if you use other tools in support of your development. Section space is quite an interesting tool. It's a 2D modeling and BIM modeling tool that we use primarily for the conceptual design phase, and it actually is very well versed for all the application to Pultrusion parts. It allows you to basically create two-dimensional geometries by either create them, importing them, or modeling them, and you can decide between thin walled and solid sections. What is interesting is you have within section space contextual menus to apply materials or laminates directly to any of the sections that you create, and you can calculate your section properties, also review load capacity with allowable loads and reserve factors, provide failure analysis, and so on. So basically what this tool does, it allows you to very quickly perform section design and optimization, whether this is for your conceptual or for some review of your initial assumptions. CompoSIDE also includes 3D finite element modeling and finite element analysis. This is in terms of a module called FE space, which is basically, as you can see, a three-dimensional part or structure finite element solver. It includes automatic meshing with the capabilities to refine some of those meshing locally. The solver supports linear backlinking and model analysis, so you can actually perform all of that extremely quick within the platform. And any analysis that is done is run in our servers. You can easily store the analysis you are interested in and retrieve as needed. So there is no longer having to look for files or to keep those results saved in a number of folders. Everything is contextualized within your model. It also includes capacities for topology management and a straight link to section space, so that once you have a structure, you can actually review the section properties, go back to the section space, modify, and rerun the final model with well, very quickly. So I mentioned earlier there are a number of automated reports. So report space is the place where one should go to look at those. It basically allows you to use the standard templates or to define your own custom templates for laminates, sections with inclusion of reserve factors, bill of material, or yacht standards for ISO and GL scantling regulations. All your reports are managed within report space. You can issue new reports, issue revision. You have an integrated revision engine, and you can then share just an HTML link internally or externally, or download and send the PDF. But as you can see, it's fairly detailed in terms of the analysis and the data it provides. And finally, the bill of material, which is part of the reports we generate. Once again, this is fully automated. So you can imagine we had in CompoSIDE, we mentioned we have the materials to which we can allocate a price. We have pliers and laminates, but we also have the models, sections, or finite element models, and all those quantities and weights are calculated through the mesh. So we're taking a real surface of those, and basically we're able to extract all this information and format it in either a summarized table within Bomgen or a detailed report with as many components as needed per material. Now, in Bomgen and for the bill of material, I mentioned the material costs, but there are also usage and wastage factors that are assigned to the manufacturing process you select during your material selection. So, for example, we'll see later on Pultrusion, which is a low wastage manufacturing process, will have a lower wastage than can be hand-layup or vacuum bag. And all of those are automatically calculated in association with the manufacturing process. So what it gives you is the weights of the materials of the part as engineered, but also the data of the materials that you need to buy or to source in order to run your project. And similar to reports, the bill of material can be issued in PDF, HTML, and supports a number of revisions, so that when you share the HTML link, you're sure that the people going to this address will always have the latest and updated bill of material for your project. Okay, so why Pultrusion? Well, you've seen there are a few capabilities in CompoSIDE, particularly section space, that make it ideal for Pultrusion. But if we look at the manufacturing process itself, what you see here is just a fairly high level and simple, well, straightforward comparison of different manufacturing processes, such as contact molding, vacuum bag or autoclave, filament winding, RTM, and Pultrusion, obviously. What this does, it just ranks from a lower to higher values a number of, let's say, score points. So, for example, the ability to work with different number of materials, the freedom you have in terms of your geometry, as well the freedom you have in terms of the maximum size of that geometry, but also in terms of overall process productivity, tooling costs, labor risk of skills and costs, and quality in terms of consistency of the products that are manufactured. And as you can see, without going into the details of all the processes, what you can see from a Pultrusion perspective, what we have is fairly, let's say, midway scoring in terms of what materials can you use. You know, there are obviously a large number of materials you can use, but we're far away from having total freedom as we have in RTM, for example. The geometry is fair that it's scored midway again, because although you have a lot of freedom in terms of the two-dimensional profile, you're obviously limited in terms of three-dimensionality of that profile. And similarly in size, it can be as long as you want, but in terms of maximum dimensions, we're not going to the same dimension what we can have, for example, with a hand layup. Pultrusion is, however, one of the most productive manufacturing processes, without doubt. It also has, as I mentioned, the lowest wastage factors. The tooling costs are fairly accessible compared to, for example, an autoclave. And in terms of labor, is not necessarily the most expensive or skilled labor required in order to provide those products manufactured. The quality is fairly consistent between one product and another. So in summary, it is something that is extremely fast, is fairly economic with a very high productivity level. It gives you, very importantly, accurate control over resin contents, which is very important when using your products in order to control the mechanical properties. Is a low wastage manufacturing process, and it gives very high longitudinal strength. There are also no length restrictions. However, there are obviously limits in terms of the size of the actual cross-section that you can represent. You are restricted to a fairly constant thickness, obviously, throughout the manufacturing process. It's a bit fairly difficult to control shrinkage of your products, and with some quick pouring processes, you may actually end up lowering your mechanical properties. So there are obviously some very good sides to Pultrusion itself. There are, however, a number of restrictions one needs to be made aware of. But overall, is a good process if you're using it for the obviously extrusion of profiles, and you're more concerned about profile definition, two-dimensional definition that is then Pultrusion. Okay, so time to go into the live demonstration.
Okay, thanks, Lorenzo. So when we jump into CompoSIDE, you'll see that I'm in my browser. So at the moment I'm in Firefox. CompoSIDE is fully web-based, so you can access it from anywhere in the globe. Anywhere, anyone can access it. So it allows you to work really collaboratively with your colleagues and other engineers. As Lorenzo mentioned, the the main workflow in CompoSIDE is left to right. So we start in project space by defining safety factors, bill of material settings, who's working on the project, who has access and who can do what. Then the next step on a project is typically which materials am I going to use. So CMDB, you can create materials, add your own materials in, import them. You can export them to other softwares, other FEA softwares, and you can compare directly different types of materials, so woods, fibers, plies, cores, and plastics. So you've got a really wide range of materials that you can compare within CMDB. Then we create a typical stack up. So in Lamina space, we can create as many plies as we want in our Lamina. We can analyze them, compare them, so the stiffness properties, the strength properties. We can add loads directly to these laminates to understand how they're reacting to these loads on a ply-by-ply basis also. Then we have section space, so this is our 2D analysis tool. We can import our sections, apply loads, work out how they're reacting again, so a very quick concept design at each stage of these modules. Then we can jump into FE space if required, so this is our 3D tool. We can create shells, frames, or just a simple beam. So it's quite versatile. You can get quite a lot of results out of deformation results. We can get element results, nodal results, and reserve factors, very importantly. And then, as Lorenzo said, we've got a couple of modules dedicated to different industries. But after this, so we've got, after the analysis stage, we've got the bill of materials. So this is where CompoSIDE has a really linked workflow. So it grabs all of the data from CMDB, Lamina space, section space, FE space, and collates it all into one module and gives you one bill of materials for the projects that you want and that you select. And then after that, we have more technical reporting. So we can get a section report out, we can get a bill of materials report, or there's some other functionalities for the laminate reports and also for the other industrial modules. So let's assume that we've set up our project and we'll jump straight into CMDB. So you can see here that I've got my active project materials. I have a few materials in here, so I have unidirectional carbon with standard modulus, and I've got a epoxy pultruded plank, so it's 1 millimeter thick. So I can layer these up or create different planks. So if I have a wall thickness of 4 millimeters, I can either create a material with 4 millimeters thickness, or I can just use these to layer them up. It's very easy to use layered materials, so a 1 millimeter standard thickness. If I want to optimize the weight, the stiffness, the cost of my product, then I can just add or remove those plies just by ticking or unticking those plies from the stack up. And I also have a few resins. So these are matrix in CMDB. I have a couple of material selections on the left here. I have two resins in here, so an epoxy and a polyester resin. Within the CMDB add-on, you get up to 10 matrix, but you can also add your own materials. Now I mentioned that you can make your own materials, so we have a module called Plygen, which is in our project materials. We can create a material, generate the physical properties, so the fiber volume fraction, the fiber weight fraction, just from the material type, the matrix material, the fiber material, and the processing type. So these properties are hardwired in by default, but you can play around with them. So if I want to create a pultruded material, I can choose a matrix material. So let's go with a polyester, and I want to create an e-glass material. So I can select this. It brings in my fiber volume fraction from the processing type, which I can obviously play around with if I think that I'm going to get a slightly higher volume fraction. I can tweak it as I see fit. And then I can create a reinforcement mass, so I can just bulk that up to make a certain thickness of pultrusion. So let's call this 1200. Okay, we're at 0.7 millimeters thick, but we can play around with it just so we get the right thickness of our modules. Then from this we get our thickness, area, weight and density. We get our stiffness results. So if we want to compare two materials with the same fiber type but two different matrices, because we want to test the mechanical properties versus the processing time. So let's say polyester is going to yield us twice as much pultruded length than the epoxy for a certain amount of time. We can just compare the mechanical properties and whether it's worth it. So very good comparison tool. So I have a couple of plank materials which we can compare the properties for. So if I right click and create a scatter plot, I can work out the density or another property against tensile modulus. So weight versus tensile modulus is quite critical. So it's the stiffness per weight. We can see very clearly that these unidirectional carbons are quite a lot higher than the glass. So we're going to create a couple of pultruded sections with these carbon properties. Okay, so these materials, you don't have to use them in CompoSIDE. You can just export them to another FEA software if you want to, or you can export them to your spreadsheets if you're using a spreadsheet. But it's just a good place to keep all of your materials in the same place. Everybody has the same access, and if you update a material, then everybody else will get that material. So once we've selected our materials, we need to create a laminate. So for this, we need to jump into Lamina space. So you can access the modules from the left of the screen. So this is Lamina space. You can see I have one laminate in here, but we'll create a new laminate as we go. So let's call this Pultrusion 2. Now we can create the base laminate name, a fiber type, and manufacturing type. So these are for the bill of material settings. So if I have a carbon, and it's going to be in pultruded, and this will take into account the bill of material settings. So how much wastage and usage we're going to use for our final product. Okay. So this is our laminate. As a typical laminate generator, we add plies, which we've already defined in CMDB. You can see that I have my pultruded plank material. This is my selection, which I've already created. And I'm going to use this UC. And let's say I want two of these. So they're both at 0, and I can add one in. But I want a chop strand mat on the outside surface just so we can fair it and coat it because the customer wants a nice finish on this. So I can very easily just add in another ply, and I can create, just using a filter, a chop strand mat. I have an e-glass chop strand mat, and I can use this and add this in above. Now this is going to be a symmetrical laminate, so I can use the sequence type to mirror this laminate. So symmetric, odd, let's go for even. So then it mirrors it automatically, and anything that I changed in the top side of the laminate will be mirrored in the bottom. If I'm just using this to mirror the laminate and I want to change around so it's a bit anti-symmetric, I can convert this to a total laminate. So I can change each of these plies individually. If I want to add a sublaminate, so let's say I want to take off my chop strand mat and understand how the section behaves without it, I can add a sublaminate and just say this is UD profiles. And I can select my plies just by dragging and selecting them. So then what Lamina Space and CompoSIDE will do later is it will analyze both of these laminates separately, and I can compare them side by side. So if I save and close this laminate, you can see that my generic data will appear. So this is my number of plies, thickness, weight, my physical properties, and my unit price if I've defined one for my materials. And we can see that we have these two laminate families or sublaminates up here. So I can compare these two sublaminates together. Now, Lamina space is calculated the engineering constant, so the in-plane and out-of-plane stiffnesses, along with the ABD matrices. It generates my allowable strengths. So I can calculate very quickly an allowable bending moment for my laminate. So if I've got just a flat profile, this may be all you need to just analyze. So I know for each failure type, I know my maximum bending moment and which ply it's going to fail at. And again, I have the allowable in-plane strains and shear strains from this. We can also apply loads directly to this, and it will give us reserve factors based on different failure modes. But you don't always have to use this. It's one of those things that you can either go so far or you can just analyze it in the next module. Okay, so we have our laminates defined. The next thing we want to do is to apply it to a 2D section. So for this we jump into section space, and I have a few different selections, a few different groups. Now this is really my section library. So if I was a Pultrusion manufacturer, I would share this project with all of my engineers so they could add the new profiles into this library, and everybody has access to this. So I have quite a complex Pultrusion, which is this one. I imported this as a DXF, so it's very easy to import as lines, and then I applied a laminate to it. So you can see if I go into it, I've got my lines which I imported, and I have my stack up, which is slightly different to the one I just created, but we can play around with this. So if I edit the laminate family, I can choose my sub-laminates that I defined earlier and save and close, and it will choose the plies that I've already defined. Okay, now from this we can apply loads and we can generate the section properties. There are a few other ways to create these sections. So we have a template generator tool where we can create 4 or 5 basic shapes. So C-beam, L-flange, hollow rectangular, or I-beam. So these are quite typical beams, and they create it parametrically. So if you imported this shape, you could apply a laminate to it, and then come back to it and play around with the shape if you're not happy with it, or you need to add a little bit of height. So it's quite a versatile tool. Okay, so we have our section calculated, we have our section defined, we have our laminates applied. We can apply a load or just generate an allowable load. So if I want to know the bending moment capacity, I can just have a look at the MY plus, for example. It will give me my allowable bending moment, so 3.73 kilonewton meters. And I can also set the failure type, so whether it's minimum, fiber failure, or resin failure. And then if I calculate this, this will give me my reserve factors and my nodal results, my axial loads, axial strains, axial stresses, and shear stresses, for example. So this may be enough just to define your section, or you may want to go further and define it as a 3D product. So what we'll do that now. I will close and save this, and then we jump into FE space. So this is our 3D modeling software module, and you can see that I've extruded this section I've just showed you as a shell model. I want to understand how each of the elements are interacting. So I put it in as a shell model, and you can see that it's just extruded it straight along a line and applied those laminates already to the geometry. So I can apply a boundary condition and load. So I've got a fully fixed at one end and just displacement fixed in one end, and applied a load. So once I calculate this, it will send it off to the server. Usually take around 5 to 10 seconds to calculate, and then you can bring it back in, and you can see how I have a list of tasks that I've already calculated. I can bring those back up into my viewer to analyze them further, compare them against each other. And I can really easily have a look at the element strains, stresses, my reserve factors for the shell, the beam, and just a reserve factor summary which I can export. Now this is a 3D shell model. There are other ways of doing it. So if I have a frame made of pultrusions, I can very easily just create, if we jump into this, I can just create a frame model with a few different sections. I haven't gone into much detail in this one, so this is just a basic frame. My load case is I have a fixed point here and a distributed load along this beam. I can calculate this using my section, so these sections are directly linked with section space. And you can see if I come into the properties, it's just a basic square pultrusion, and it's brought in and linked my section properties to it. I can jump back into section space from this module, so if I go into edit, I can directly change this, so if I want to change the height, the laminate, the width, whatever, I can do it, and then jump straight back into the model, into the 3D model. Okay. So I've already calculated this. It took 8 seconds to calculate, and you can see I've got some deflection results. I can check my element beam results. So if I want to find out the reaction at this point, I can have a look at this from my internal forces. I can work out the bending moments on this. So I can really understand the structure in quite a basic model. And then in my reserve factors, I can calculate my reserve factors, understand where it's failing, and then bring this load back into section space just by clicking on the button. So I've got my results. I can play around with the beam. I can add or remove a few plies. So if I jump into the stack, I can remove 1 or 2 plies, save it, and then when I can calculate this load again, which will be the same load assuming that the stiffnesses are fairly similar, and then optimize it in section space, and then jump back into FE space just for the final check that I've got my deflections and my reserve factors okay. So it's quite a quick way of analysing a frame if you've got a very quick check to do. You don't have to go into a detailed FE model and start working with shells where you have to change the geometry if you update a laminate or something like that. Okay. So this is our analysis done. We're assuming that this is all okay. We need to generate a bill of materials which we can send away to the manufacturer or the material supplier to order our materials. So CompoSIDE, what it's done is it's grabbed all of the data from the work that I've been doing, and when we jump into BOMGen, so this is our bill of materials generator, we can update this, and you can see that it's brought in all of these materials. So I've got my chop strand mat, I've got my unidirectional carbon plank, and it's given me areas and weights for the product and the resin. So this gives you quite a detailed breakdown. Now from this we can generate more detailed reports, so you can create a more detailed bill of materials report from this, or we can create a section report. So let's do that. So let's jump into report space, and you can see that I've created a report here, Pultrusion section. Now this is our basic template. You can create your own or use ours, modify ours. It's really up to you, but you can set one, and then everybody can generate a report based on this template. So we can export this to an HTML or generate a PDF, download it, and send it onto someone. And this is really good for versioning of reports. So if I have my section and I've changed my laminate, I want to update it, I can just create a new issue, and then everybody knows that this is the latest issue, this is the latest materials for this section. And really this can be shared with the whole design team, from manufacture to concept designs. It's quite a good way of sharing this data. So in the report you can see there's quite a detailed breakdown of section properties, and I have a load in here, so I've chosen to export this load. It gives me my load, the actual load that is applied, and a basic results section based on the reserve factors, but you can get this a bit more detailed if you really want to. Okay, so that is the main workflow in CompoSIDE. Just to go back over the workflow, so we created our materials or assigned our materials to the project. We created a stack up in Lamina space, applied that stack up to a section or a few sections in section space to our libraries, and then we did a quick 3D analysis in FE space, and then we got all of that data and brought it into BombGen to get a bill of materials, and then created a few reports out of this. Okay.
Okay, thank you, John. So, where are we? Okay, here we are. Okay, so that was it for the live demonstration, which brings us to a few concluding notes before going to question and answers. So overall, if you look at what CompoSIDE can offer for the design of parts for Pultrusion, it is fairly ideal. It's very much of a conceptual engineering tool, which is very well versed for the definition of the sections and the extrusion, the checking with 3D, but also application of those sections to more complex grillage parts. There is a data set which features Pultrusion-specific material data. So actually you can use this data in terms of the material properties, the usage and wastage factors that are applied to the manufacturing process to get closer and realistic data as to what will be the final product. We have today spoken a lot about composite supplies and resins, but obviously Pultrusion is something you can do across pretty much any, well, a lot of materials, and CompoSIDE does support multi-materials, so including metals, woods, plastics, so it's something that you're able to use for composite, but also for non-composite materials. John mentioned that it can act as a centralized library, and this is something actually quite interesting for CompoSIDE, where being web-based and being a multi-user environment allows you to really put all those libraries into a centralized place, accessible to all, where they can review, document, enhance, or even present those results internally or even externally. Which brings us to the point that will be covered also in the next slide, is the ability to basically share data with distributors or with clients in order to create additional value to basically your offering. CompoSIDE is something that can be used to primarily from an engineering management point of view as a secure centralized platform for engineering activities. It's very well to cover all the basic engineering requirements. It is a development tool that can be used for Pultrusion profiles or biomaterial manufacturers that want to just review how their materials would work compared to other materials in a given section or a given profile. It can be used as a central library and as a demonstration tool, whether by distributors or even for sales, so in support to their activities. And there are also some of our clients that actually are providing CompoSIDE to their own clients in order to help them make faster decision, quicker, let's say, purchasing process, and tying those relationships between the two. If you've not, for example, seen one of those examples, it's a couple of months ago, we had a webinar in collaboration with 3A Composites, where CompoSIDE has been basically modified to suit the need of 3A to provide a system for automated bill of material generation for marine vessels, so sailing yachts or motorboats. But what is important there is that we go back to this concept of a centralized library, which is made accessible to their salespeople to their clients, and they can basically just log in, look at some of the products they have, and immediately get all the data they need in terms of how much weight, how much materials they need to make a certain product. There is a recording link here that can then be accessed through the presentation once it's shared. So in terms of benefits to our users, CompoSIDE is a tool that can help you improve your engineering efficiency. It's easily accessible and scalable, as we say. It results in savings of days of engineering resources. One obvious aspect is a bill of material for a fairly complex structure is something that, whereas will probably take a week, normally speaking, can be basically automated and generated at the click of a button. It can improve quality and consistency of deliverables through the automatic report generation and your own company templates. And all of that can basically help in reducing the project costs, improving the margins, or making you more competitive in the marketplace. Now, as far as CompoSIDE goes, we also have dedicated support and training. This is done both for the software and the engineering applications. So if you're looking at, or if you'd like to try the software, there are video tutorials available. Those are over 70 tutorials showing you how to do the main steps, but also how to, for example, create beams and panels, run analysis. Within CompoSIDE, there is a live chat function, so our support team is available immediately if you have a quick question. Otherwise, email support, but also frequently asked questions and demonstration webinars. CompoSIDE comes with a very detailed knowledge base and technical documentation explaining all the main features of the software, while we also provide dedicated training and engineering services in support to your engineering activities. So it can be a second look on a project or on a product, down to training for composites application or specific industries. Okay, we're now coming to the question and answers. I think we have 5-6 minutes to look at this. So if you have any questions, in the right-hand side, you should have a little questions panel that you can use to type in your question. We'll try to answer all of those. If we miss some, we'll get back to you with via email or phone in the coming days. Our first question is, getting closer. Our first question asks if we can have some arched profiles in CompoSIDE rather than just the linear ones.
Yeah, so if you can create the geometry within FE space, so we can create arcs, we can create NURB surfaces, NURB curves. So anything you have an edge to, you can apply a load to. So if you have, for example, the edge of a panel, you could be able to apply it to that. So you can have curved panels, you can import your step file, which then you can import your beam sections to and apply it to. So CompoSIDE is very versatile with regards to importing geometry, or you can import curves as well. So there are a lot of things that you can apply it to.
There was a question, John, someone joined later during the presentation. He asked if we could share the link. So yes, as you register, you'll get the registration link the video recording link via email as soon as it's done, probably the next couple of days. There was a question on the usage and wastage factor for the materials. Where do we get that data? It's primarily out of experience that we had with the processes. The way to see it is that CompoSIDE can offer you a baseline once you log into the platform, and you are then able to refine and adjust those according to your own specific project, as I mentioned, both on a company level, if you did the manufacturing improvements, but also on a project level, so that you're able to see what it would mean if you were to change some applications. Okay. Okay, if there are, let me go here. Oh, this one. Okay, if there are further questions, please feel free to either write at support or my address. You see that displayed on screen at the moment. CompoSIDE is available on a free 30 days trial, so you can start your own Pultrusion profiles. You can import your own files. You'll see and see exactly how it works and where it can be of benefit to you. Otherwise, we thank you for your participation today. Hopefully, you had a good time and learned something new. And we may be seeing you soon on CompoSIDE.
Okay, thank you everyone.
All right, thank you.